you are given the above data on the age of students in a primary school. Which of the following is not true about this data? So this table, this frequency distribution table, is about the age of the students in a certain primary school. So we are asked which of the given alternative is wrong about this information. So let's see each of them. The first one, the median is 10.5. Normally, we do have a total of 40 students here. 5 with 15 is 20, 28, 38 with 2, 40. So the total number of students here is 40. So let's check the median. The median means the middle term. Okay, so the middle term is the 20th and the 21st. I mean, the middle term is the average of the 20th and the 21st term. So the median of this data is the 20th term plus 21st term over 2. Basically, the 20th term is 10 and the 21st term is 11. So this is 10 plus 11 over 2, which is 10.5. So the median of this or the median age is 10.5, so it is true. Let's check for the mode. Mode is the highest frequent element. The highest frequency is 15, so the highest frequent element is 10, therefore the mode of this data is 10. So B is also true. We are searching the wrong statement about this data. The mean is the average value, so the mean can be calculated from this frequency distribution. The mean can be calculated by 8 times 5. We multiply each values by their corresponding frequency. Then 10 times 15 plus 11 times 8 plus 12 times 10 over, plus 13 times 2. We multiply each values by their frequency over the sum of the frequency. 5 plus 15 plus 8 plus 10 plus 2. Normally they are 14. So this value will be, the sum of this value will be 424 over 40. You can simplify by 4. 106 by 4, 10. 106 by 10 is 10.6. So the median of, the mean of this data is 10.6. So this is 10.5. Approximately they are the same, but let us consider this is not correct. But approximately you can say it's correct, but exactly the mean of this data is 10.6, and the range is the difference between the highest value minus the lowest value. The highest value is 13, the lowest value is 8, so the range is 13 minus 8, which is 5. So still D is correct. So the wrong statement about this information is C. The second problem is the following is a table of simple frequency distribution of a data with variable x. With variable x, then the standard deviation of the data is how much? So when we have a certain frequency distribution, to calculate the standard deviation, always we need to calculate first the mean. So the mean of this data is multiply 1 by 2, 1 times 2 plus 3 times 5 plus 4 times 6 plus 5 times 5 plus 7 times 2 over the sum of the frequencies, 2 plus 5, 7, with 6, 13, with 5, 18. So the sum of all this frequency is 20. So this will give us the mean. So the mean of this data, if you add the numbers in the numerator, it becomes 80 over the total number of the data set. So the mean is 4. So now let's calculate the variance. The variance, denoted by sigma square, is calculated by this form. We take the difference between each element with the mean, 1 minus 4, 1 minus 4, we take the difference and square it, then multiply by the frequency, plus again take 3 with 4, the difference between 3 and 4, square it and multiply it by the class frequency, plus take 4 with the mean, 4 minus 4, the whole square, times the frequency of the class, plus 5 minus 4, the whole square, times the frequency, plus 7 minus 4, the whole square, times 2, over the total number of the data set, which is 20. So actually you can construct, to avoid a mistake, you can construct a table that describes the difference, the squared values and everything. So here this becomes the difference here is minus 3, square it 9, 9 times 2 plus minus 1 square is 1, 1 times 5 plus 0 times 6 plus, this is 1, 1 times 5 plus 3 square is 9 times 2 over 20. So this value becomes, you can multiply it and the result is 23 over 20. I mean 46. This is 46 over, it's 46 over 20. The simplified form is 23 over 10, which is 2.3. This 2.3 is the variance, it's not the standard deviation. So this is 2.3 is the variance, therefore standard deviation or the sigma is square root of variance, right? Square root of variance. So this is the standard deviation. So from the given choice, our answer will be B. A school has 3 classrooms for grade 11, namely 11A, 11B, and 11C. There are 3 sections in 3 grade 11 sections in a certain school. The number of students in these classrooms is 28, 20, and 22 respectively. All the students took an examination and the average score of the students in 11A, 11B, and 11C is 60, 70, and 70 respectively. What is the average score in this examination for all grade 11 students? Here we do have the information about the number of students in all the 3 classes, 28, 20, 22 respectively, and the average score of each section is given 60, 70, and 70. So let me give a notation for each. So the average score for section A, or the mean score for section A, is 60. The mean score of section B is 70. The mean score of section C is also 70. This is the information. The other thing is the number of students in section A is 28. The number of students in section B is 20, and the number of students in section C is 22. Okay, this is the information that we have. So the required thing is, it is required that the average of all the sections. Okay, basically the average of all section, when we want to calculate the average of all section, we need to know the score of all section, the sum of the scores of all section over the total number of the students, the total number of the students in all section. So we need this thing, but here we know that the average or the mean of section A is the sum of the students, the sum of the score of section A students. They are 28. We add the score of all the 28 students and divide it for 28. This is the mean of section A, which is 60. Okay, and the mean of section B is calculated by adding the score of each students in that class, the score of each students, 20, the score of 20 students over 20. This is 70. And the mean of section C is calculated by adding the score of all 22 students, the score of all 22 students, and dividing for 22. This is 70. Now from this we can get that by using crisscross, the sum of the score of the section A, the sum of the score of section A is obtained by multiplying 60 with 28, and the sum of the score of section B is obtained by multiplying 70 with 20, and the sum of the score of section C, the sum of the score of section C can be calculated by multiplying 70 by 22. So here we need to do some little calculations. So this result, 60 by 28 means 1680, and 70 by 20 is 1400, and this one is 1540. So we do have the score of each section. Now the mean of all section, the average or the mean of all section is the score of all section 1680 plus 1400 plus 1540 over the sum of all the students in the three sections. So totally in all the three sections there are 70 students, 28, 20, 22. This is totally 70. So we can sum it up, this one, 4620 by 70. Okay, you can simplify this thing. 462 by 7, the result is 66. Therefore the mean or the average of all the section is 66. The average of all the class is 66. So this is the required answer. The marks of students scored in an examination is grouped in class intervals as shown below. So this table is a grouped frequency distribution table containing the marks of students. So the question is, what is the median of the mark? Literally, median is the middle term, but we have a formula for finding the median of a grouped frequency distribution. So the median for a grouped distribution table is given by BL plus n over 2 minus CFB over FC times I. Now this BL refers to the lower class boundary of the median class. N is the total number of the data set, for this case the total number of students. CFB means the cumulative frequency before the median class. CFB is the cumulative frequency before the median class. FC is the frequency of the median class, and I is the class interval. Now I will tell you each of them separately. There is a class interval here. So BL, to know BL, or the lower class boundary of the median class, we need to determine first the median class. Now let's count the total number of the students. 8 plus 12, 20, with 20 is 40, 46, 50. You can add all this thing. The sum of this number is 15. Therefore, 50 is the number of students. Okay? So when we divide this into two equal parts, you will get 25. So 25 will be in the third class. The first 8 students are here, up to 20 here. Then the middle term, the 25th student, will be in the third class. Knowing this median class is very important. If we don't know the median class, we cannot find BL, we cannot find CFB, we cannot find FC. Okay, so knowing the median class is very important. So the median class is the third class, or the third class is the third class is the median class. Okay, so we have the median class. Now we can determine BL. BL means the lower class boundary of the median class. This is lower limit and 84 is upper limit. So you will subtract 0.5 from the lower limit, and you will add 0.5 on the upper limit, so that you can get the class boundaries. Now BL will be 74.5, because when we subtract 0.5 from 75, BL will be 74.5 plus N is 50. 50 over 2 is 25 minus CFB. CFB means cumulative frequency before the median class. The median class is the third class. In the third class, the frequency is 20, but the frequency before the third class is 12 and 8. So add 12 and 8, that is the cumulative frequency before the median class. So in place of CFB, you will substitute 20 over FC, means frequency of the class. Which class? Frequency of the median class. So the frequency of the median class is 20. So use 20 in place of FC times I. I is the class interval. That means the interval containing 55 up to 64. So the class interval for this frequency distribution table is 10. Okay, you can check the class frequency including 55 up to 64. The class interval is 10. Now The remaining thing is very simple. It's a matter of adding and multiplying. So this becomes 25 minus 20 is 5. 5 over 20 times 10. So this becomes 74.5 plus 2.5, which is 77. So the median for this group is 77, or the median score is 77. Therefore, our answer is C. If the list of a measurement is 10, alpha, 5, alpha, 5, 10, 20, 15, 25, with mean x bar, then what is the value of alpha in terms of x bar? So x bar refers to the mean. We know that the mean of the data can be obtained by adding all the elements. You can add all these things, 10 plus alpha plus 5 plus alpha plus 5 plus 10 plus 20 plus 15 plus 20 plus 5. We add all the data sets over the total number of the data set. So the total number of the data set, you can count all these things. Okay, you can count them. They are 10. Okay, so this means we have 2 alphas, 2 alpha plus you can add all this number, 10 with 5, 5, 10, 20, 15, 25. You can add all this number, it becomes 90 over 10. So the mean in terms of alpha is given by 2 alpha plus 10 plus 90 over 10. You can use crisscross. So 10x bar is equals to 2 alpha plus 90. So solving for alpha, 10x bar minus 90 is equals to 2 alpha. Now you can divide it both sides by 2. Alpha becomes 10x bar over 2 minus 90 over 2, which is alpha becomes 5x bar minus 45. So alpha in terms of the mean can be expressed in this form. Therefore, the value of alpha in terms of mean is in D. The following is the frequency distribution of a grouped data. We have a certain frequency distribution table here. Then what is the mean and the standard deviation of the distribution respectively? Here we are asked two things, the mean and the standard deviation of this frequency distribution table. So to calculate the mean and the standard deviation, we need to write this table in more simplified form, or in detail that contains every information. So to make things easy here, I have constructed this table. The question is about the mean and standard deviation of a certain information. Here we do have class interval and frequency. Here, as you can see, I have constructed a certain table which contains class interval, frequency, class mark, the product of frequency and class mark, the difference between class mark and the mean, the square of this deviation, the product of the frequency and the deviations. So let us feed here the intervals. The interval is from 3 to 7, the second class from 8 to 12, the third class from 13 to 17. So this is arranged horizontally, but I'm just writing here vertical columns to use less space. And the last class is 18 up to 22. These are the classes, and the frequency of each class is 2, 2, 10, and 6 respectively. 2, 2, 10, and 6. 6 is the frequency of the last class. Let me tell you the rest. XC refers to class mark. Class mark means the value that represents the first class. The first class is 3 up to 10. So the average of 3 up to 7. The average of 3 and 7 is 5. So class mark is halfway between the upper limit and lower limit. And the class mark for the second class is the average of 8 and 12, which is assumed to be midway between the boundaries. And the class mark for the third class is 15. You can add 13 with 17 and divide by 2. The class mark for the last one is 20. So this class mark tells us the average values in each class. So f times the class mark means you multiply the frequency by the class mark. The result is 10 here. Multiply the frequency by the class mark, 20, here 150, here 120. I multiplied every frequencies by the class mark. Then in the next column we need the difference between the class mark and the mean. The formula for the mean of a grouped frequency distribution is the summation of the frequency times the class mark over the sum of the frequency. Okay, so here the sum of the frequency times the class mark is, you can add all this thing, the result will be 120 with 150, 270, it is 300. Okay, therefore this value is 300 over the sum of the frequency is 2 plus 2 plus 10 plus 6, which is 20. This 300 over 20 is 15. So the mean of this data is 15. So x bar, or the mean of this data, is 15. Now take the difference between 15 and xc. Okay, we use the difference between each xc, or the class mark, and the mean. So take the difference between them. This is 5 minus 15, which is minus 10. Here 10 minus 15 is minus 5. Here 15 minus 15 is 0. 20 minus 15 is 5. Okay, here in this column I take the difference between each class mark and the mean. Okay, I used this column. So squaring this column will give us the square of minus 10 is 100. The square of minus 5 is 25. The square of 0 is 0. The square of 5 is 25. Okay, so now we multiply this squared deviation by the frequency of each class. So frequency times this squared deviation is 200. The frequency of the second class times the squared deviation is 50. The frequency is here 10 times the squared deviation. The frequency of the fourth class times the squared deviation, which is 150. Okay, so now we need the sum of the product of the frequency with the squared deviation. So the sum of all these things, 250, 0, 150. The sum of all these things is 400. Now we can calculate the variance. The variance is given by the formula, the summation of the frequency times the squared deviation over the sum of the frequencies. So this value is 400 over the sum of the frequency, means the sum of this 2, 2, 10, 6. The sum of the frequency is 20. So this becomes 20. This value is variance. The variance is 20. Therefore, the standard deviation becomes square root of variance, which is square root of 20. Or you can write this thing as square root of 20 means 4 times 5. 4 can be taken out from the radical. It becomes 2 root 5. So the mean, we are asked the mean of the data, which is 15, already obtained. The mean is 15, and the standard deviation of this frequency distribution is 2 root 15. So we are asked these two things, 15 and 2 root 5 respectively. So our answer for the given problem is 15 and 2 root 5, which is A. So the answer for this problem, we are asked the mean, which is 15, and the standard deviation, which is 2 root 5. If Qi, Di, and Pi are respectively the i's, quartiles, deciles, and percentiles of a data arranged in increasing order, then which one of the following is necessarily true? So it's about the quartiles, deciles, and percentiles. So we are asked the statement which is necessarily true. So obviously the quartiles and mean of the data are not necessarily the same, so this is not true. The 25 percentile and the first quartile are the same, so P is not greater. P25 and Q1, the first quartile, and the 25th percentile are the same. So C and D are not necessarily true. The A case, the second quartile is the average of the third quartile and the first quartile. Unfortunately, this is true. The second quartile is the average of the upper quartile and the lower quartile. This is true. The third decile, which is the third decile, is the same as the 13th percentile, which is strictly greater than the 25th percentile. So for this question, by chance, we do have two answers which are necessarily true. Therefore, we can take A and B as an answer. The next problem is, the following is a set of data representing the average mark of 30 students. Okay, these are the marks of 30 students. So for this score, then which one of the following statement is true about the data? So to answer this thing, we need to first arrange this information in increasing order. So the smaller number is 85. Put 85. Then the next number is 87. Okay, we need to arrange these 13 datas. Next to 87, we have 89. 89 is written how many times? 89 is written 2 times. So 89, 89. After 89, we do have single 90. Okay, after 90, we have 3 91s. 1, 2, 3. There are 3 91. Okay, 91. Then after 91, we do have a single 92. After 92, we do have 93 here, 93 two times. 93, 93. After 93, we have a single 94. And lastly, we do have 96. So this is our data in ascending order. So the median will be, we have to make sure first whether it is 13 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we do have exactly 13 score. The median will be the middle term, which is the 7th term. 1, 2, 3, 4, 5, 6, 7. The median is 91. So A cannot be a true statement. The range is the difference between the maximum and the minimum. The maximum is 96, the minimum is 85. So the range is 11. So automatically B is a true statement about this data. We can also check that the rest are false. The upper quartile is 92. Basically, the upper quartile means Q3. Q3 for odd number of data, we calculate Q3 by 3 times n. Our n is 13 over 4. Okay, the upper quartile is this item. Okay, so when we calculate this item, it becomes the 10.5th item. The 10.5th item means an item which is halfway between the 10th term and the 11th term. This is the 10th and 11th. They are the same. Halfway between them, there is nothing. It is 93 itself. So the upper quartile is not 92, it is 93. Okay, the upper quartile or Q3 is 93. And the mean of this data is the sum of all these numbers. We add all these things. Okay, we add all the values, 85 plus 87 plus 89. We add all these things up to 96. You can use your own calculator. It's very simple addition. And we divide for 13. The result is 90.8. So the only statement which is true regarding this data is the statement in B. Therefore, our answer is B. The following is a simple frequency distribution of a data with variable x. What are the mean and variance of this ungrouped data? Here we have a certain frequency distribution. For this given frequency distribution, we are asked the mean and the variance of this data. So it's very simple. Let's calculate the mean. We use the formula to calculate the mean by the sum of the product of the frequency with the variables over the sum of the frequency. Okay, so let us multiply each variables by the frequency and add them. We multiply this number. Okay, we multiply these numbers and we add them. So the product of 3 with 2 is 3 times 2, 6, or 5 times 5, 6 times 2, plus 7 times 1. We add all these products. We add all these products over the sum of the frequencies. We add all these frequencies. we add this thing, 2 plus 5 plus 2 plus 1. So this result is 6 plus 25 plus 12 plus 7 over the sum of the frequency is 10. So we add this thing 50 over 10. The result is 5. This 5 is the mean of the data. Okay, so to save space, let me use here the mean of this data is 5. We have this mean, so we have already obtained the mean. The next thing is calculating the variance. So the variance of the data is given by this, it's represented by this symbol, and the formula is the sum of the product of each frequencies of the variable times the squared deviation from the mean over the sum of the frequencies. So we first calculate the deviations of each element from the mean. So this means we multiply the frequency 2 with the first element, or the first variable is 3 minus the mean, and we square it, plus again take this one, 5 times the variable 5 minus the mean, the whole square, plus again take this frequency, 2 times the variable 6 minus the mean, the whole square, plus the frequency 1 times 7 minus the mean, the whole square. We subtract the mean from each these variables. We subtract the mean from each variables. Okay, we subtract the variables 3, 5, 6, 7. We subtract from each variables. We subtract the mean from each variables, and we square it. Then we will sum it up. Then finally we add the frequencies. The sum of the frequency is 10. So this result is 2 times 3 minus 5 is minus 2. Square it, it becomes 4, plus 5 times 0 plus 2 times 1 plus 1 times 4 over 10. So this result is, this is 0. 8 plus 2 is 10. 10 plus 4 is 14. 14 over 10 is 1.4. Okay, therefore the mean of this data is 5, and the variance of this data is 1.4. So our answer will be D. There are 3 children in a room, aged 3, 4, and 5. The age of these 3 children is 3, 4, and 5 respectively. If a 4-year-old children enters the room, then which one of the following is true? Now let us put everything here. Let us write the age of these children. The age of these children is 3, 4, 5. Now the question is, which one of the following is true about this information? When a 4-year children enters to the room, what will be the mean and the standard deviation? Originally, the mean of these 3 children is 3 plus 4 plus 5 over the total number of children, which is 12 over 3. So the mean of these children, the 3 children, the average age of these 3 children is 4. Now one boy or girl is added to this group with age 4. What will be the mean and the standard deviation? Normally, the mean of the new group will be, the new group will be, call it x bar. X bar is 3 plus 4 plus 5 plus 4. So we divide it for 4. The result is again 4. You see, the mean will remain the same whenever a certain child with 4 years entered to the room. The previous mean and the new mean are the same. Okay. So let us also evaluate the standard deviation. So let us calculate the standard deviation for the 3 children. To calculate the standard deviation, we need to calculate the variance first. The variance of the 3 children is 3 minus the mean square plus 4 minus the mean square plus 5 minus the mean square over the total number of children. This is 2 over 3. This is the variance. Therefore, the standard deviation of the 3 children is square root of 2 over 3. Okay, this is the standard deviation of the 3 children. Now let us also evaluate the standard deviation of the four children. So to calculate the standard deviation, let us say sigma prime square is the variance of the four children. So it becomes 3 minus 4 the whole square plus 4 minus 4 the whole square plus 5 minus 4 the whole square plus 4 minus 4 the whole square. We divide it by the total number of them. So this is 0 and this is 0. The result is minus 1 square is 1 and 1 square is 1. 1 plus 1 over 4, which is 2 over 4, meaning that 1 over 2. So the standard deviation of the 4 children is square root of 1 over 2, but the standard deviation of the 3 children is a square root of 2 over 3. So you see, when a 4-year child entered to the room, the mean remains the same. Both means are the same, but the standard deviation, it was radical 2 over 3. Now it becomes radical 1 over 2, which is getting less. So let us see the choice. The mean age will stay the same, but the standard deviation will decrease. It was radical 2 over 3, now it is decreased to radical 1 over 2. Therefore, the answer for this problem is B. The age distribution of student in a certain class is given. The age distribution is given in this table. We are asked the modal value of the distribution. So we have the formula for the mode of grouped frequency distribution table. The mode denoted by M naught is given by BL plus D1 over D1 plus D2 times I, where this BL is the lower class boundary of the modal class. D1 is the difference between the frequency of the modal class and the preceding class, and D2 is the difference between the frequency of the modal class and the subsequent class. Now, first of all, what is mode? Mode is the highest frequent element. Now, let's check the frequency of each class. 2, 10, 6, 10, 7. These are the frequencies. The highest frequency is here, 10. Okay, so 10 is found in the second group. So in the second group, the lower class boundary the lower limit is 15. Therefore, the lower class boundary is 14.5. We subtract always 0.5 from the lower class limit to get the lower class boundaries. So our BL is 14.5. Again, listen, this D1 is the difference between the frequency of the modal class and the frequency of the preceding class. The frequency of the modal class is 10. The frequency of the preceding class is 2. That is D1. D1 is the difference between the frequency of the modal class and the subsequent class, which is 8. And D2 is the difference between the frequency of the modal class and the subsequent class. So the difference between the frequency of the modal class and the subsequent class or the next class is 4. So we use these values BL, D1, D2. I is known. I is class interval. You can see starting from 10 up to 14, the interval is 5. So let us substitute all these things. That will be the mode of the distribution. So BL is 14.5 plus D1 over D1 plus D2 times I. I is already 5, the class interval. So this is 14.5 plus 8 over 12 times 5. By 4, 2, by 4, 3. So this becomes 14.5 plus 10 over 3. So this is 14.5 plus approximately 10 over 3 means 3.3. So this becomes 3.33 and so on. So this becomes 17.83. This is the value of the mode of the given distribution. Therefore, our answer for this problem is B. The variance of 20 observation is 5. The variance of 20 observation is 5. If each observation is multiplied by 2, then what is the variance of the resulting observation? So here we need to know some fact. If we multiply each observation by a certain constant number, the variance will be changed. The mean will be changed. The standard deviation will be changed. Everything will be changed whenever we multiply a certain observation by a certain constant number. Here, there are 20 observations, and the variance of this 20 observation is 5. Then we are asked what will happen, the variance of the new observation when each of them are multiplied by 2. So let us say let x1, x2, x3 up to x20 is the observations. Okay, obviously we know how to calculate the mean, the sum of all the observation, the sum of all the observation divided by 20 is the mean of the original observation. Okay, when we multiply this observation by a certain constant, k times x2, k times x3, and so on, the new mean will be changed. K times x20, k times x20, the new mean represented by x prime is changed into k times the old mean. Okay, you can check by taking a certain numbers. For example, if you take numbers 1, 2, 3, 4, 5, obviously the mean of this data is 3, and if you multiply all this thing by 2, the number the mean of this data is 3. You can check. If I multiply everything by 2, it will be changed into 2, 4, 6, 8, 10. Now the mean of this data, the new mean becomes 6. You can check, the new mean becomes 6. That means if every observation is multiplied by 2, the new mean will be a multiple of 2. Okay, it's twice the mean of the previous observation. So when we talk about the variance, when each observations are multiplied by 2, the new variance will be quadrupled, because the variance is given by the formula, the sum of each observation minus the mean, square it over the total number. Okay, so when we calculate the new variance, it will be the summation of kxi minus kx bar, the whole square over n, where this k is common, so it becomes the sum of k square, k is common, k square into xi minus x bar, the whole square over n. So this becomes k square times the summation of xi minus x bar, the whole square over n. So this is the variance of the old data. Now the variance of the new data will be a multiple of k square times the old variance. Now assume this k is 2. Therefore the new variance becomes 2 squared times the old variance, which is 4 times 5. The resulting variance will be 20. Okay, so for this observation, the new variance will be quadrupled whenever each observation is multiplied by 2.